Okay. Uh, Today we'll start with the fourth unit, and actually in fourth unit there are two chapters. One is the kinetics of rigid body and another one is kinematics of rigid body, right? So in these two chapters, first we'll start with the kinematics of rigid body, and actually in this chapter there are very easy topics which are covered. One is the introduction about this, then plane motion of rigid body, then velocity and translational and rotational motion and relative velocity. That's all. Now when in this it is said that it is the plane motion of the rigid body, this plane motion means he is talking about the general plane motion of the rigid body, and we'll discuss you what do you mean by this general plane motion actually. Then second chapter in this is kinetics of rigid body. In this there are small topics in it: force, mass and acceleration, work and energy, impulse and momentum, D'Alembert principle and dynamic equilibrium. Actually whatever is there in this complete chapter, maximum content you had already covered during your 11th or 12th class, but you are not gone into the basics of it. Whatever you have done the shortcuts, especially in case of general plane motion numericals, right? So we'll try to cover the basics in it. Okay, let us first start with the just small information, but that is very important, about kinematics. Kinematics is the branch of dynamics which actually deals with the motion of bodies, but without considering the forces which are responsible for that motion, right? I'll again repeat it. In kinematics, it is the branch of dynamics which deals with motion of bodies, but in that dealing, forces are not considered which are responsible for providing motion to it. Whereas in case of kinetics, we deal with bodies in motion along with the forces which are actually responsible for it. So this is what the kinetics, and this is what in kinematics, right? Okay. Then very simple, in this different types of motion when we'll study, it is called as translatory motion, okay, then rotary motion, and then general plane motion. I'll tell you what do we mean by translatory motion, right? So for that, okay, see, if I have this let's say object, and this object will go like this, right? This type of motion is called as translatory motion. It is going in a straight line, right? It is called as translatory motion. Okay. Second is, and that too translatory also, but translatory in a rectilinear way. What do you mean by rectilinear? Rectilinear means this is the surface and it is going like this. It is going like this. This is called rectilinear motion, right? Then when we say curvilinear means motion in a curve. It is going like this, motion in a curve, right? It is going like this, motion in a curve. This is called as curvilinear motion. Then third one is called as general plane motion. What do you mean by this general plane motion is, see, this, when it is moving and in rotation also, then it is called as general plane motion. The body is moving also and it is in rotation also, then that type of motion is called as general plane motion. The example of general plane motion is motion of wheels of any automobile. Any automobile, when it moves, it rotates and that wheel rolls, and that rolling is called as general plane motion. In between translatory and rotary and general plane motion, what I left is rotary motion also. Rotary motion means it is in rotation, right? This is the example of rotation, that it is a ball which is attached to a string, and this ball is in rotation like this. So it is moving along its own axis like this. Now, very interesting example of general plane motion. These are the two. One is very easy, that is called as motion of wheels. But you can also see another example is ladder sliding down from its position. Okay, what do you mean by this? It means that any ladder which is sliding down, that means if ladder is placed like this, it will slide down. It will slide down, right? But as such, from this wording, that ladder sliding down from its position, it does not mean that, it does not seems to be an example of a general plane motion. And I think you will also convince with me. Ladder sliding down from its position does not, one can directly imagine that this is the example of a general plane motion. But we'll see that this is the example of a general plane motion, right? So these are the three different segments, and rotary motion also I had already covered. Rectilinear motion, rectilinear translatory motion, then translatory curvilinear motion or curvilinear translatory motion, right? Okay, let us see some equations of it. These are the different very easy equations that you had already known to you. Equations of linear motion. One is the v is equal to u plus at, then v square is equal to u square plus twice as, then s is equal to ut plus half at square, right? Then this is another, the velocity v is equal to ds by dt, and acceleration a is equal to dv by dt, and this dv by dt is further I can write down as d2s by dt square, right? Now in case the motion is due to gravitation, then we'll change this a into g, whatever the condition is. That means if any body is moving towards upside, that means if any object will go towards upside, then we'll say this as positive. We'll say g as positive. But sorry, negative. It is going against the direction of gravitational force. So we'll say this is negative. But if it will go in the direction of gravitational force only, then we'll take this as positive, right? Okay. Just analogous to linear equation of motion, these are the equations in case of rotational motion, and that is omega is equal to omega naught plus alpha into t, theta is equal to omega naught into t plus half alpha t square, and omega square is equal to omega naught square plus twice alpha theta, and omega is equal to, same way the differentiation formulas in the, as we is already seen in case of linear motion, same in rotary motion, right? Now we can discuss some of the numericals which are based upon it. Okay, let us quickly see first numerical. In this, it is said that a small steel ball is shot vertically upwards from top of a building 25 meter above and the ground with an initial velocity of 18 meter per second. In what time it will reach the maximum height? How high above the building will the ball rise? Compute the velocity with which it will strike the ground and the total time it is in motion. Okay, let us see the solution of it. It is like this. Let's say this is the building and this is the ball, 25 meter height of the building. From this stage someone is throwing it upside into the air. Then let's say it reaches to this height, then it will go down and it will strike at the bottom by some velocity. Let us say that velocity be vg. Let us say t be the time till it reaches the highest value of it. Let us say h be the height till it goes, right? Okay, and one point it is very easy and clear to me, that as it will reach to the top, its velocity will be equal to 0. That means in this case, in this particular case, my initial velocity is only 18 meter per second, but my final velocity is 0, and I need to calculate h and t. And we already know, everybody knows that in this case what will be a will be minus g, and that's what we'll do. We'll put values to this equation, that is the first equation, v is equal to u plus at, and we already put values to it, and time we already got that in 1.83 seconds it will reach to its highest position. And what is that highest? H is equal to ut plus half gt square. From that we can get the value of 16.51 meter. Then the third is, what will be the velocity when it will strike back to the ground? U is equal to 0 and twice gh, and h is equal to 25 plus 16.51. So it has given me v is equal to 28.538. So in this way you can see very easily that these numericals are very easy and you can solve it very quickly, right? Okay, so next numerical. A stone is dropped into a well, is heard to strike the water in 4 seconds. Find the depth of the well, assuming the velocity of the sound to be 335 meter per second. Okay, now question is that I was having a stone over here, and this stone was dropped, and as it dropped, its sound came just after 4 seconds, right? So from this stage, once it is dropped till the sound comes at this point only, it is the time is 4 seconds. So total time is 4 seconds. T1 is the time in which this pebble or a stone reaches to the water, and T2 will be the time in which the sound from this point to this point reaches, right? So we can easily get the value of T1. Let us say from this equation, h is equal to ut plus half gt square. We know that initial velocity is 0 and h is equal to half gt square. Then from this equation we will get T1. Then another equation is v is equal to d by t, or t or T2 is equal to h upon 335, and then T1 plus T2 is equal to 4 seconds, and this is the equation, and if we square it, and we'll get the value of h from this. This is the depth of the well, right? So that's how we can solve this, and there are some more numericals that we'll discuss in next class. Thank you.